Module 3, Proportion, Ratios, Rates, and Percents. This is Section 3.6, Weight and Mass, U.S. and Metric Systems of Measurement. When you're talking about a weights object, you're talking about either ounces, pounds, or tons in the U.S. system. Since there's less options than length, you'll have to deal with less conversions. There's 16 ounces in 1 pound, and there's 2,000 pounds to 1 ton. You can write ounces on top, the smaller, of the larger measurement of the 1 pound, or you can have it the other way around. What you're converting to is what you'll want up on top. So if you're converting to ounces, you'll have ounces on top. If you're converting to pounds, you'll want pounds on top. Convert 9,000 pounds to tons. So we're going to want tons on top. We're talking about 9,000 pounds. I know that there are 2,000 pounds in 1 ton. Since I want to go to tons, tons needs to be on top. I'll multiply straight across. If you have a whole number, there's an invisible 1 underneath. And so I have 9,000 over 2,000. And pounds will divide out. And now I have tons. 9,000 divided by 2,000, well, I can simplify the zeros, will give you 4.5 tons. Decimals are fine. You can also write this as 4 and 1,000 over 2,000, which of course reduces to 4 and 1/2. If you want to go pounds to ounces, I know there's 16 ounces in 1 pound, and I want to go to ounces, so ounces will need to be up on the top with pounds down in my denominator, and I'm converting pounds. I have a visible 1 underneath my 5 pounds. Multiply straight across. Pounds will divide out, and I'm left with 16 times 5, which is 80. And so 5 pounds is the same as 80 ounces. Sometimes you don't want to write it in decimal form like we did when we were converting pounds to tons, but you want to know the leftover part in the smaller measurement. 38 ounces. I'm going to convert that to pounds and ounces. If I want to go to pounds, that means pounds will need to be up top. There's, in 1 pound, 16 ounces. I'll leave my 1 underneath there. I'm going to divide this piece out, and when I multiply straight across, I get 38 over 16, and that's how many pounds I'll have. Well, 16 goes into 38 twice, but that would leave me a remainder of 6. The large answer up on the top here, the quotient, is how many of the larger pieces you have, and your remainder down here is how many of the smaller pieces that you have left. You won't need this anymore. And it will always work this way, that this is the larger portion, the larger measurement, and this guy is the smaller, the remainder. Sometimes when we want to add and subtract, we saw with addition and the length one that we had more than we needed to make a foot or to make a mile. But sometimes when you subtract, you can't actually do the subtraction. If I want to take 3 tons and 1,295 pounds from 7 pounds, 1,000 pounds, this should say tons, then 7 minus 3 is fine, but I can't say 1,000 minus 1,295. So I'm going to need to borrow. I'm going to take this and drop this down to 6 tons. And I'm going to take that extra ton, which is the equivalent of 2,000 pounds, and I'm going to add it to this portion right here. So that my problem will turn into 6 tons, 3,000 pounds. And then this would be minus 3 tons, 1,295 pounds. Now I can subtract each piece. The order does not matter. So 6 minus 3 is 3, so I'll have 3 tons. And then 3,000 minus 1,295 would be, we'll have to do a bunch of borrowing here, or you'll have to add up. This would be a 10, 9, 9, and then a 2. So I have 5, 0, 7, 1. So my answer would be 3 tons, 1,705 pounds. When you're working with metric, you're going to have a lot more options, but it's going to follow that same acronym that we used for the length, which is King Henry died, and then remember we use by here, drinking chocolate milk. The prefixes never change. It's the extensions. Before we were talking about length, so we were talking about kilometers and hectometers. Here we're talking about mass, so we're going to be talking about grams. Before, this was 1 meter in the middle, but now we'll be talking about grams. That's why I leave this as a by, because it could be meters, like it is for length. It could be grams, like it is here. It could also be liters, like it will be in 3.7 when we talk about capacity. A paperclip weighs about 1 gram. A box of crackers is about 453 grams. It's a little bit harder to eyeball grams than it is for pounds. A kilogram is a little over 2 pounds. It's like 2.2 pounds. If I want to convert 360,000 milligrams to grams, well, I'm at milligrams here, and I would have to go over 1, 2, 3 spots to the left to get to grams. So that means I need to take my decimal point, which I can't see, which is here at the end, 1, 2, 3 spots to the left, and I'll have 360 grams. Remember, there's 10 of the ones underneath in the one that's bigger. So there's 10 milligrams in 1 centigram. There's 10 centigrams in 1 decagram. There's 10 decagrams in 1 kilogram, and that's how it climbs up. So it's all by multiples of 10. Let's do some practice. I have King Henry died by drinking chocolate milk, and where my by here is going to be grams. So if I have kilograms in A, I'm starting here and I want to go to grams. So 27 kilograms, I'm going to have to go 1, 2, 3 spots to the right. So I'm going to take this decimal point 3 spots to the right. So 1, 2, 3, and I'm going to have to put in my zeros, and I'm talking about 27,000 grams. If I'm going from milligrams to grams in D, 1035 milligrams. How many grams? Well, now I'm going to be going the opposite way. So here's milligrams. I'm going 1, 2, 3 spots to the left. So 1, 2, 3, and I'll have 1.035 grams. Let's look at E. I have 8,360 centigrams, and I want to go to kilograms. So not starting on the M, now I'm starting here at this C, and I'm going all the way to here. So I have to go 1, 2, 3, 4, 5 spots to the right. So I'm going to have to jump over all these numbers. There's 4 of them there, and 1 more. So I have 0.08360 kilograms. Pause the video and see if you can find B and C. We won't worry about F because you don't see hecto or hecti very often. Okay, let's look at B and C, and I'm going to put up a fresh King Henry. Oops, I lost my Henry. Chocolate milk. There we go. B. 310 grams. I'm going to kilograms. So I'm starting here in the middle and going 1, 2, 3 spots to the left. So 0.310. And for C, I have grams. So I'm starting at the by and going down to milligrams. So 1, 2, 3 the other way. So I have 22,000 milligrams. When you're adding and subtracting these, you need to convert so that they match. So I need this both either in decagrams or in regular grams. So King Henry died by drinking chocolate milk. So there's, if I have decagram here and I want to go to gram, I have to go one spot to the left. So my 5.4 DECI would go one spot to the left, and I'm talking about 0.54 grams. Or I can take my grams and turn that to decagrams and go one spot to the right. If I want my answer to be in grams, then I would say 1.6 grams plus 0.54 grams. I'll need to add in a little 0 right there so I can, I want to subtract. So I want to subtract these. I'll need to borrow. And so I have 6, 0, keep my decimals, and then there's nothing to subtract there. So I'm talking about 1.06 grams. If I'm going the other way, and I want it in decagrams, I would have 16, and then I would have 5.4. Remember, when you're adding and subtracting decimals, you need to string those decimals together. I'll need to borrow again. So I have the 6 here, and it'll be 10.6. And you can notice that if you wanted to change deci over to gram, you would go one spot to the right, and so you would land with the 1.06. There's no right or wrong way that you always want to go larger or smaller. You just do whatever one that they ask you to do. And that's how you change units of mass.